USDTV 笠山です。
Just hand it a URL or a link, just click on it, and it works everywhere, on every browser, on every device. So if we take a look at the stack of a native application, we see, we know this is a UI layer that sits on top of view logic, which works with a business logic, which interacts with a persistent layer, sometimes with an ORM. And what is this? How is this work? Okay. So the difference between the two is that the web page has a static UI. At least at the beginning, the UI was really static. It was pure HTML. And between the UI layer and the view logic, we have the network, introducing the latency that we always have to deal with. So I think that what we are consciously or not trying to do since the very first years of the early 90s is just make pages fully interactive. And in order to do that, we first need to be able to change the appearance of the page without reloading the page, because reloading the page is not instant. We have this very ugly blank screen that bothers the user. So in 1995, we were just trying to figure out how to make HTML pages, and then boom, JavaScript landed on the browser. And the first thing that we thought we could use JavaScript for was make snowflakes fall on the page. That's why I say that we may not be really conscious about the opportunities of JavaScript at that moment. But then things went on, and we really wanted to be able to load new content on the page without reloading the page. But then we had to wait 10 years and have AJAX requests. And then we were technically done. We were able, at that point, technically, to build a fully interactive application within the web page. But we didn't go straight to the point, right? We all know that we had a really big problem of separation of concern, because at that time, we still sent chunks of HTML through the wire in response to AJAX calls. So both the front end and the back end were concerned by page composition. So, and also, we didn't have Node.js. So we were writing in JS on the front end, and then on the back end in Ruby, PHP, or Java, whatever. So in 2010, first generation of UI libraries came out. I'm talking about Backbone, Angular, Ember, and many more, but those are the most famous. And what happened at that moment is that we were able to pull the view logic out of the backend and just leave that concern to the front end and make the server just expose a REST API and make pure JSON data flow through the wire. So we were able at that point to split concerns and teams, which was great. We just had to make a contract between the front end team and the backend team, and that was a human problem, very easy to solve. And then we were done. It's okay. Calm down, Steve. Look at how the native application engineer did the UIs. And look at how we did the UIs. That's the code that we needed to write in order to nest the view in another backbone view. And when I realized that, I felt pretty much like this. We definitely needed to do something. And at this point, it's really a concern of developer experience. And it's very interesting for me what drives those innovations. At a certain moment, it was just user experience. Now, it's developer experience. Be more productive. 2013, second generation of UI libraries, React, Angular, Vue.js, Polymer, Psycho.js, many more, which introduced a lot of new things, but here what I'm interested about is the concept of component. Components, as we all know, are the basic bricks that we build our web page with. And the interesting thing about components is that we can really describe every aspect of that chunk of interface in the same place. What I show you here is a Vue.js component that I really like because it's very clear. You have three tags: style, template, and script. And that's all you need to define a component. The beauty of this is that each aspect is defined in a different language, and the language is very specialized for that precise thing. Also, components. We are offline, even if all our assets are stored in the browser cache. We want to access a website. We've been there yesterday, and now we're offline. We see the dinosaur. Native applications don't do that. You open a native application and you have some content that you've been visiting before. You can see it. We have the dinosaur. Why? Let's kill the dinosaur. Let's provide the user with some real, compelling offline experience. And then what we are doing today is first-class applications, web application. And why wouldn't be present among the other application of the user? Why don't we have an application icon within the application menu of the user? And then native application can bother the user with push notification. Why shouldn't we do that? Actually, all these things are possible today, and they are known in this terms. Progressive web application is like a technology bundle that Google pushed forward a lot. And which really, to me, is the last step that we need to make in order to provide a real, fully interactive application-like experience to the user. But unfortunately, it's not supported by all the browsers. Guess who is supporting that? Chrome and Firefox. Let's see what happens. My dream is actually to be able to leverage all that technology and really, make a real application in the web with web technologies. Data. I want to talk about data because we've been talking about UIs, and that's one thing that we deal with, and then the other thing is data. We always have to manage how the data flows through our application. And the main problem is what happens when data changes. The main promise that all the UI libraries we use is to keep the data in sync with UI. Or the opposite. UI lines encrypted data. Okay, this is a piece of junk code that I show you. So please, children, don't do that at home. Okay. Here, where's the data? Because we check the DOM, and then if the menu is closed, we put the class, and if the menu is open, we remove the class. So where's the data here? managing all the data caching for us. They are managing all the request optimization for us, and we'll see that in a moment. And they just let us specify that we need and just wait for the data to arrive. In this case, we are introducing a new OGM layer to the front And I say OGM because Falcor and Relay work with graph, because actually it's the best way to model our data. And the interesting thing here is that we are starting to consider the backend as some sort of resistance layer that we about. We just know there's some sort of latency, and that we don't bother about it. Demo time. That's when things... Okay. This is what I have in my backend. Let me just resize the window. This is a list of products that my REST API just responds when I ask to search for the products. I have these are Italian food that I sell to my colleagues at Caso. And we have all these useful and less useful fields, okay? There's especially this one and this one. And now I want to be able to query those fields. So what I make here, okay, I'm here. I'm demonstrating Falcor, okay? It doesn't mean that I think that Falcor is the best solution ever. It's just that Falcor isn't coupled with React. Since I'm not a React developer, I use Vue.js. It was just the best solution for me to show you the idea behind the thing. So here is, we are querying with Parmesan cheese that I want to see, and this is the title, okay? And then, get value returns a promise. The real type is actually unobservable, but it really behaves like a promise. So I said, then, when the data is available, I want to show it. So here's the data, okay? Okay, let's take a look at, this is the query, am I right? Yeah. Yes, this is the response of Falcor, okay? It just sent you the title. What happened on server side? Let's see. This is my Falcor code on the server side. Falcor on the server is just an express middleware that you just plug a router to and then specify what your routes do. So, okay, this is my router create class, and then I define a route. This is the matching pattern. So that's how I tell Falcor what do you have to match in order to enter this route. And then I specify the method, which in this case is get, because I just want to get data. Methods can be get, set, and call. So in this case is a get, which always returns a promise. And then here, this is my code. It's just I make a call to Kazor to get some data, and then when the It's okay? Okay. So basically when the data come back, I have my title. So now let's try to ask another field here. Say I want to get the description of my product. Okay? I have an error. Yes, it's always the same, because I always get called by this. In fact, when you want a value, you use get value, so you just have the value. And when you want multiple values, you use get, which actually returns a JSON graph object. So here you can see I have my title and my description. But look at the response of the second request. Falcor knows that I have the title in cache. So even if my query was asking two fields, it tells the server, okay, just send me just the description field, because I already have the title. And what I really like about it is that Falcor tries to make this metaphor, to create this illusion to the developer, which is just code as if the data was present on the local machine. Just like it was synchronous, okay? Like, don't worry about where comes the data from. I just manage it. And so, what if we could code like really everything was here and we could synchronously get the data? Map the state to the DOM. But all the frameworks that we use implement this in different way. Events, dirty checking, virtual DOM, reactivity. I think that data binding should be embedded into the language. And this is what Jafar was about. I think that a really key solution, the most elegant solution to this problem. And actually, all the RxJS implementation are going through this direction. I hope that the RxJS implementation will be embedded into JavaScript soon. This is one of my dreams. And I also want to talk about virtual DOM. Virtual DOM is great because it introduces this abstraction, which actually works very well. And it's also good for performance. Because imagine we have a DOM change. We trigger it, and then the browser goes on and restyles, relayouts, and repaints everything. This is very costly. Another DOM change, another round of restyle, relayout, and repaint, and so on. What the virtual DOM does is buffering the DOM changes, and then trigger them, flush them all at once, and save a lot of calculation of restyling, relayouting, and repainting. I was asking myself, why don't we make virtual DOM native? Why don't we make browsers expose some kind of virtual DOM API, something that would allow us to say, hey, look, I have this change, just buffer it, then this one, and this one, and this one, and then just flush it. And then you do all the calculations. Obviously, virtual DOM also computes diffs, so it doesn't mean that virtual DOM would be completely useless, but I think that virtual DOM libraries would be lighter. In order to achieve the largest amount of users and in the end make them happy. I think that we have a lot of things going on in our community because the problem is complex and it's not solved. And we are finding solutions that are just awesome. Think about the network abstraction introduced by Relay and Filecore. This can benefit all the industries that work with distributed application. An iOS developer, an Android developer would benefit from having the network abstracted and don't have to bother about it anymore. So from our community, we are really introducing this great innovation that we can spread around. And if you take a look at how the front-end environment evolved, we can see that the stack is not very different from the native application stack, especially if we consider that the backend is like a persistence layer that we abstract. Today we have a front-end that embraces the full stack. And I think this is possible because the language that we use has evolved a lot, and it's now a first-class application programming languages. And I'm obviously talking about JavaScript, which is the language of our community, the language that we use every day to express the problem that hassle us every day when we wake up. We are people that work a lot, that are really concerned by this problem. We spend a lot of time working on free open source projects. We spend a lot of time on the social network trying to communicate with other people and find solutions, maybe arguing sometimes a lot, because this problem.
It's very easy just to start writing test cases. And this piece is the first thing. Before you start writing test cases, you need to know what you're trying to achieve. Okay? And the other rules, the 9 rules, will fit into this because they're all reflections of why you're doing all this sort of stuff. Okay? So as Stuart said, he wrote some tests for a little tiny thing. He found out that actually what he was doing was he was capturing the behavior of the system. Right? And that's what we're doing. Right? Tests are, at one level, sort of like the inverse of your code. This is your test capture. You've embedded in your test what you expect the behavior of the code to be. So when you're writing tests, you should be thinking about the most effective way to do that. Right? What you don't want to do, what lots of people do, is they go, I'll do code coverage or test coverage. I'll do the easy bits. I'll write tests for all the getters and setters because that's easy. And it's like, well, that doesn't really help because they're going to get tested anyway. What you want are test cases that explain to you and to your descendants when they pick up the test suite what the test was trying to do. And obviously what it's trying to do is exercise the code in a particular way. So we want to talk about, you don't use this, we talk about testing quality in. So if you're going to test your product, do you use test cases to test quality in? And we have a good conversation about what quality meant. And so that's what we came up with. More likely this is about writing test cases for embodiment of the behavior of your system. And you only have so much time. You get, as I quoted at the beginning, you only get so much time to do this. If you spend all your time writing simple test cases, you're not doing yourself a favour. So you should forget about those sorts of things and focus on the important activities that you should put in your test suite, not the bits and pieces. So Stuart, what do you think about, we had this conversation about testing in quality. Do you think that's a reasonable thing to achieve, or do you have an opinion? Right? I think there's definitely an opinion, yeah. There's a subtle relationship between testing and quality, and I think it's very interesting listening to people talk about them, and there's a lot of subtleties often lost in those conversations. And the way I think about it is that you spend a lot of time talking about quality, but this is not a quality talk, this is really talk about testing. And so testing is a measurement of one aspect of quality, which is the functions that you intended to do. And so if you have some software, you intended it to perform some functions, the tests are verification that those functions are implemented correctly. Now, those functions are valuable to the customer, or whether they run fast enough or something like that, that's kind of a separate issue, and other aspects of quality that we can't cover here. But I think it's a measurement or verification of functional aspects of system. And occasionally you run into, I certainly run into project managers in the past where, they'll say, this product doesn't have enough quality, or this product is low quality, therefore we should write more tests. And it's like, no, that's not quite right. There's something more fundamental going on. Yeah. Now maybe if it may be that hypothetical project needed to improve its quality, and so a bunch of things happen to be bug fixing or better design or refactoring or something, and as part of that effort, better tests need to be written, maybe fewer tests need to be written, some garbage tests might need. So a whole bunch of activities regarding testing No, you can only test the quality that is already there. Yeah. And we all know, if you write more tests, you find more bugs. So if you try to test quality, you'll never finish, because every time you write another test case, you probably find another bug. Yeah. Okay, so let's move on to number 2. Stuart, do you want to kick this one off? Yes, okay, so make your tests understandable. So here's a bunch of interesting things about code quality, comments, behavior diagnostics, and so forth. And so what this is asking really is, what's the relative importance of your tests versus the quality of the code in your product? And occasionally you'll hear somebody say something like, okay, oh gee, there's, this code in this test over here isn't very good, maybe we should go clean it up. Nah, that's just test code, we don't need to worry about that. And I think that's a mistake, because tests are just as much a part of the software system as the product is itself, because you need to understand it, you need to maintain it, and as you evolve the product, you also need to evolve your tests. So both are living things. And so I think it's a mistake to say, gee, that's test code, that's unimportant, because that will get in your way in the future. So see, what happens if your test code is not well maintained and not understandable? You spend a long time trying to figure what's going on. So if you have test cases that you can't understand, so I go back to the first point about the testing of your test is important in the behavior of your system. So if you read a test case and you go, I don't know what it's trying to do, well then how do you know it's supposed to work well at all? Okay, you get somebody says my test failed, and you go, is it because it's the wrong test, that it's badly coded? Is it just because you don't understand how it works? So if you don't make your test understandable when you write it, it's like when you come back tomorrow or 6 weeks time and you try to understand what's going on, you go, what did I do that for? Right? So the other way of looking at this is this whole thing about debugging your application takes twice as much brain power as writing it. So we should use half the brain in writing the code. Okay, and I can point out that actually it's the same as testing. Right? If you put all your effort into fantastically hard code, then your tests are going to be fantastically hard times 2, and then you have to remember how to debug them. So if you add it up, if you have really complicated tests that you don't understand, you need 4 people to figure out whether it's working or not. So you have to start right at the beginning. So it's simple, easy, well commented, understandable tests. Right. Number 3. So related to that, keep your tests small and simple. So what we mean by that is where if you look at tests, sometimes it's really hard to work out which bit of this code is the test. Right? Now it's easy if you've got frameworks that have got like JUnit that can do assertions and things, but if you don't have that, or you only have one of those, and you go, I can test with lots of if statements, and then there's an assertion that says this thing should not be null, and you go, well, yeah, but which bit of all this code did it work it out? Right? So you want to start thinking about, you want to keep it separate. So you have all these frameworks have great setup and tear down stuff. It's so much easier to separate out your tests, you keep them as small as possible, makes it easy to understand, and as you'll see later on, actually means execution benefits. Yeah. You agree with that? I think so. Cool. Yeah. I think it's really things that seem sort of obvious. You have 2 tests, you have set up, perform an operation. That's about it. But it's obvious until you run into a test suite that you inherited from somebody else where that wasn't followed. Yeah. And then sort of this test is doing a bunch of stuff. Is this the setup? Is this an assertion? Or something, right? And so anyway, so yeah, do this. Do that. Yes. Okay. So I think you're next. Yeah, right. Yeah, that's one thing only. Okay. Oh, right. Okay. So yeah, so it's actually this kind of a continuation of what I was just saying. And so when you have a test case that has this well-structured setup, operation, verification, and teardown, then put only one operation or one test scenario in each test. And it's a very important rule to talk about, but it's also a little more subtle. So if you have a well-structured test, what I find some people do is they say, okay, I have some setup code, and I do an operation, and I do some assertions. Well, while I'm here, I'll test this other thing, do some assertions on that. Oh, and okay, there's that other thing over there, and I can do some assertions on that. So we end up piling a bunch of operations and assertions into the same test. And the problem there is that now you're mixing a bunch of different concerns. So maybe the third operation actually had a subtle dependency on the first operation being performed correctly, and if it didn't, then if your first operation left something in the state of the system or the test fixture that wasn't caught properly in assertion, it might cause a failure downstream, and now you have a big debugging chore in your hands. So maybe you got an assertion halfway through, it's like, well, why did you do it this way? Now, instead of saying, okay, I have some setup, I can perform the operation, and then you can go in with the debugger or logging and tracing and figure out what's wrong at that point, you have to go through all of the stuff that led up to it in order to get to that point, because you haven't separated out all the different test cases that were being tested for there. Yeah. But do you agree with that? Yeah, I do. This is terrible. Not any advertising. So I was thinking about circumstances where this has been broken, and one of the things I've seen over is test cases that have 100 asserts in them, right? And then there's another test that's 50 asserts, and you go, you've got this, people get carried away. It's very good to write asserts to say, I just called this method and returned something, did not lie. It shouldn't be null. And that's great, but then you also test something else and the same thing happens, right? And it's like, why are you doing that? Right? What you want to be able to do is go, it's very clear to me what I'm testing. Is that test testing the very first assertion or the very last assertion or all of the assertions? Now there are times when it's reasonable, a scenario, to say, I'm going to be cool, I'm going to get a complex object back, I'm going to make some assertions. Because if you don't do that, you might find that you're doing lots of calls to get objects back, and you're wasting effort. But if you just generally keep going, assert, do something, then it many daughters. And if you mix your scenarios because it's complicated, then you're doing the same thing. So you want obviousness. So you can go, I failed, and then faster debug, right? Which one failed, right? This one here, let me put a breakpoint on that point, easy to see. You have to work through the code to work out that's the thing that's important. Then again, if you fail. Okay, yeah. Fast test only, yes. So this is a cool one, right? Because you have to think about, the idea of the opposite. So let's think about testing. So what you want to do is you want to run your tests instantly. So I write some code, I enter code, I save it, I want things to run, right? We can't do that because we know our tests are, something that by nature are going to take a long time. I don't have infinite supply of compute power. So I want to get away, I want to